Okay, second topic is energy. Okay, what is the meaning of energy? Energy is defined as the capacity of a system to do work. When work is done, the energy is transferred from an object to another. The amount of work done is equal to the amount of energy transferred. Energy exists in many forms. For example, kinetic, gravitational, sound, heat, light, electricity, and all. Okay, in this chapter, we only consider the mechanical energy. The two types of mechanical energy are kinetic and potential. Okay, kinetic ability to do work by virtue of having speed. For example, a speeding car, and then potential is ability to do work by virtue of position or condition. For example, a suspended weight, a stretch bow. Okay, so energy ni dia sebenarnya capacity of sistem to do work, tenaga apa ni untuk kita jalankan kerja. So dia berkaitlah dengan work. Okay. So kalau kita tengok example kat sini, kita ada dua kan, energy, kinetic and potential. Okay, untuk kinetic energy is the energy of an object due to its motion. When a force does work on a body so as to increase its speed, then the work done is a measure of the increase in the kinetic energy of the body. So maksudnya kalau tengok raja kat sini, dia akan ada force. Dia sebab dia nak tolak troli ni, dia need a force, and then dia bergerak, dia ada due to its motion. So dia ada pergerakan kat sini. So dia ada V lah, maksudnya increase its speed. Dia ada V, velocity, and then dia ada distance. Okay, so figure above shows force F acting on an object of mass M. The object which initially at rest moved with an acceleration A over a displacement S. Okay, so tadi kita dah tengok formula untuk work done equals to W equals to Fs. Formula of motion, okay, yang ni kita dah belajar juga formula ni. V square equals to U square plus 2AS or equals to 0 plus 2AS because U is equals to 0. And then from formula of Newton's law, F equals to MA. Okay, so apa gunanya tiga-tiga formula ni? Okay, from equation 2, okay, daripada equation ni kita ada 2AS. This one kan, okay, 2AS equals to V square. So S equals to V square over 2A. So kita dapat yang ni. Okay, then by substituting 3 and 4 into 1, maknanya kita ambil yang ni dengan ni, kita masukkan dalam 1 sebab yang ni nilai F. Okay, then yang ni nilai S. Okay, so kita masukkan dalam equation number 1. Okay, so we get W equals to Fs. Okay, so yang ni daripada F equals to MA. Kan, okay, formula ni from, sekejap saya tulis kat sini. Okay, this one from F equals to MA, which is Newton's second law. Okay, then this one from V square equals to 0 plus 2AS. Okay, so kita ada S kat sini, kita ada F kat sini. So bila kita ganti, kita akan dapat this one formula W equals to 1 over 2 MV square. So yang ni kan kita boleh nampak tak? Kita cancel kat sini. Okay, so dapatlah 1 over 2 MV square. Since the work done is transferred to the object as kinetic energy, therefore the formula for kinetic energy EK is given by E equals to 1 over 2 mv square. So kita assume dia sebagai energy. So formula ni adalah 1/2 mv square. Okay, kita tengok example. What is the kinetic energy of a 1200 kg car travelling at a velocity of 25 meter second negative 1. So kalau awak nak bezakan antara energy dengan work, so energy dia ada kelajuan, laju which is 25. So we use formula of kinetic energy 1 over 2 mv square. So 1 over 2, your m is 1200 and v equals to 25 power of 2. So this one is the answer, 37500 joule or 375 kilojoule. Okay, this one table show that the masses and velocity. Okay, Hassan mass 95, velocity 4.8. Hussein mass 48, velocity 9.5. So which of the boys has greater kinetic energy? Okay, so kita kena kira setiap energy untuk Hassan dan Hussein. Okay, so untuk Hassan 1/2 darab dengan M, which is 95, and then darab dengan velocity, which is 4.8 square. So this one is energy of Hassan, 1094.4. Kinetic energy of Hussein, okay, sama juga, kita gantikan M equals to 48 and V equals to 9.5. So we get 2166 joule. Therefore Hussein has greater kinetic energy than Hassan. Maksudnya Hussein ni dia lagi ada kinetic energy. Okay, so you can try solve example 38. So yang ni dia dah bagi dah 400 gram. So make sure tukar pada kg kan. Untuk M, you need to change to kilogram. This one kan. Yang ni dari mana 1000 sebenarnya sebab kita tukar ni. So this one is M. M is 400 divided by 1000. Jangan guna 400 sebab yang ni unit dia gram. And then V is 3. So this one V is 3. So you get kinetic energy of cricket ball. Okay, then kinetic energy of cricket ball is equals to kinetic energy of golf ball. So dekat sini untuk golf kita dah tahu dah, kita dapat 1.8 sebab dia sama kan. Okay, since dia sama, so kita boleh letak kat sini 1.8 equals to kinetic energy of golf ball is 1/2 100 over 1000 multiplied by V square. So V equals to 6 ms negative 1. So tapi kena kira dulu lah cricket ball sebab untuk dapatkan kinetic energy, sebab dia kata kat sini equal kinetic energies. Okay, then this one untuk example 39, dia bagi mass 4 and then decreases its kinetic energy by 32 if initially it had a speed of 5 ms negative 1, find its final speed. Okay, so mula-mula kira dulu initial kinetic energy, which is 1/2 mv square, so you get 50 joule. Okay, then final kinetic sebab dia kata decrease its kinetic energy by 32. So daripada 50 dia decrease minus 32. So yang tinggal cuma 18 joule. So kita gunakan 18 joule untuk final kinetic energy. Okay, 1/2 multiplied by 4 multiplied by V square. So V equals to 3 ms negative 2. Sebab dia apa ni, dia decrease kan. Decrease its kinetic energy, maknanya daripada 5 ms negative 1 dia dah jadi 3 ms negative 1. Okay, so this one you can try solve example 40. Yang ni dia ada contoh dua solution. Yang senang sebenarnya kita guna yang ni lah, sebab kita just guna mv square. Yang ni sebab diguna V square minus U square ni sebab V square diambil sebagai halaju akhir ataupun final, and then U square adalah halaju awal ataupun initial. Okay, then this one solution for B. B ni dia nak apa? A body of mass 5 gram increases its speed from 200 to 300. So yang ni dia berubah kelajuan. So kita boleh ambil kelajuan akhir adalah 300 tolak dengan halaju awal 200. So dapat 125 joule. Okay, so then potential energy. Okay, the potential energy of a body is the energy stored in an object due to its position above the earth surface. The energy that possessed by virtue to its position. Okay, so kalau kita tengok kat sini, potential energy dia kata bila stored in an object due to its position above the earth surface. Bila kedudukan ni dia berada di atas. Okay, figure above shows a crane lifting an object. Work is done to lift the object. So yang ni crane ni dia angkat satu objek, so dia ada work done. Okay, the object gains an amount of energy that equals to the work done to lift it. So objek ni pun dia akan ada energy yang sama dengan work done. The work done against gravity is a measure of the increase in the potential energy of the body. When a body is lowered vertically, its potential energy is decreased. Okay, when a body of mass mkg is raised vertically a distance h meters, so the change in potential energy is equals to work done against gravity equals to mg h. So potential energy ni dia bergantung kepada h, which is ni kedudukan dia, kedudukan yang ni. Dia ada H. Biasa kita guna S kan, jarak kan. Okay, tapi since dia ada apa ni, dia objek ni berada di atas, so dia akan ada height kat sini. So this one lah about potential energy. So formula dia adalah mgh. Okay, example 41. Find the potential energy gained by a body of mass 5 kg raised through a vertical distance 10 meter. So just guna formula mgh. Untuk yang first, m dia adalah 5 and then h dia adalah 10. So dapat nilai potential energy. Okay, b, m is 60 and then this one h equals to 5 and then last one a lift of mass 1 ton. Okay, 1 ton ni kita kena tukar pada kilogram juga. So 1 ton is equals to 1000 kilogram multiply by 9.81 and then multiply by 20 means 20 is the vertical distance. Okay, yang ni pun sama untuk example 42. Find the change in the potential energy of a child mass 48 kg when ascending a vertical distance of 2 meter. Okay, so macam mana kat sini change in potential, kita boleh guna formula mgh. Okay, mgh, so m is 48, g 9.81 and h equals to 2 sebab dia kata kat sini 2 meter kan. Okay, kalau b, okay, b 48 multiply by 9.81 multiply by 2. Okay, tapi yang ni kita boleh bagi penerangan kat sini, the child is losing potential energy or losing its potential to do work. Sebab apa? Sebab dia descending, vertical. Yang ni ascending kan. Okay, c, c pun sama, guna formula mgh and then also d. So either loss or equals to work done. Okay, so that's all for energy. And then last one for power ataupun kuasa. Power is measure of the rate of which work is being done. If 1 joule of work is done in 1 second, the rate of working is 1 watt. Okay, so kalau power ni kita ambil formula dia work done divide by time. So yang ni kena consider masa. Okay, so kalau tengok example 43, each of the diagram below show a particle moving along a straight wire under the action of a constant force. In each case, the particle travels the length of the wire in 5 seconds. Find the work done by the force and the average rate at which the force is working in each case. Okay, so dia nak work done and then average rate at which the force is working in each case. Okay, kita tengok yang first ni. Okay, kita nak cari work done untuk first. Kita guna formula Fs. Just Fs je sebab dia selari kan dengan horizontal. So, your F is 6, S is 10 meter. So, rate of working, maksudnya kita ambil W divide by T. Okay, so 16 divide by 5 equals to 12. So, yang ni lah rate of working ataupun mewakili power. Sebab formula dia kat sini work done divide by time. Yang ni time dia dah bagi dah 5 seconds. Okay, for B, the component of the force in the direction of motion is 50 cos 60 degree sebab force dia tak selari dengan horizontal. Okay, so work done, kita boleh ambil formula F cos theta multiply by S, which is 50 cos 60 degree multiply by 8. So you get 200 joule. So 200 divided by 5 because 5 second. So you get 40 watt. Okay. So boleh tengok example 44. Height dia adalah 2.5. Okay, so kita nak kira work done, you can use formula MGH sebab dia melibatkan crane. Crane ni dia kan dia vertical tadi kan, saya dah tunjuk dah vertical. So kita guna formula MGH, work done dia MGH. Since dia ada H is 2.5 and then divide by T, which is 3.5 sebab dia bagi kat sini nilai T. So you get 5886 watt. Power, this one untuk power. So that's all for chapter 5. So you can try to solve this tutorial part A and part B. Semua dah ada jawapan dah kat sini. Cumanya kat sini saya assume dia adalah chapter 5 sebab saya ikut pada syllabus. Tapi still lagi nota ni dalam chapter 4 kan. Okay, tapi kalau ikut syllabus dia masuk dalam chapter 5. So untuk chapter 5 kita akan ada work, energy and power. 3 benda ni kena fahamkan. Okay, so that's all for chapter 5.